All right, looks like everybody is here. Then let's get started. Good morning, everybody. Today is going to be super straightforward. We're continuing practice with those fancy quadratic techniques on how to solve higher power polynomials. And once again, my system is not cooperating, so I have zero sound. If you want a visual, you'll have to join the Zoom. And if you want to ask questions or make any comments, you're going to have to use the chat there. So first off, let's roll back to yesterday's problem set and review. Here are my answers for those, some of which are a couple of years old, and I apologize. My handwriting on the screen was not that great. It's still not great, but it's a little bit better. So 17, I believe I placed down here for whatever reason. I was looking at this morning thinking, what the heck was I thinking? This one's here, that one's, I don't know. It's been years, right? But here they are. Okay, come to the full solution. I give you better than just the answers. I worked them all out for you. You're welcome, okay? So we can, first off, this does not end in a constant. GCF out the m squared. And now, oh wait, now it is a quadratic. Okay, we can just factor that the normal way. Notice that the m squared also, first step ZPP, this whole guy, either this equals 0 or this whole thing equals 0. If m squared equals 0, that means either the first m was 0 or the second m was 0. We have a root at 0, but it's a double root. Right? This is what happens when you get, say, regular parabola, basic y equals x squared, right? It touches the parabola right there. You get that double root right on because you have the double x times x. The first x could have been the 0 or the second x could have been the 0, right? If you factor that all out and you don't rely on writing the exponents, you use the definition of exponents, it's x times x. So every x that gets multiplied could have been the 0. So you end up with a double root there at m equals 0. And this guy factors 3 and 4, so you get -3, -4 to add to your list. So your list of possible root values is 0, -3, and -4. But I should have 4. Well, that's because the 0 is secretly a double. Does this make more sense? Okay, that multiplicity thing there can trip you up. All right, that was 17. Let's see, 18, I believe I stuck up here. 18, same thing, GCF first, and then you've got the a cubed there. That's going to give you a triple a equals 0. This guy factors to 1 and 5, so you get -5, -1, and 0 on your list. And 19 over here. Move the 9 over. Don't try to take the, you could take the 4th root of 9. I guess you will end up with the same answers there. But properly speaking, move the 9 over. It's a difference of 2 squares. You get b squared -3 or b squared plus 3. And that we can use ZPP on and solve each half, either b squared equals 3 or b squared equals -3. Square root both of those, and you get, this is not really a proper method here, but I wrote plus or minus the square root of positive or -3, right? It's the most condensed way. I was trying to cram things into very little space here. Well, you would end up with plus or minus square root of 3, and plus or minus I root 3, right, would be the square root of the -1. Okay, going a little out of order because it's here. Here's 21. Use that good old u substitution. Swap the d to the 4th for a u squared. And now you can factor that rather simply. to u minus 8, u minus 4, and then sub back in, so it's d squared equals 8, and d squared equals 4, square root both of those. Square root of 4 is 2. The square root of 8, 8 being 2 times 4, you can take the square root of the 4 part, pull that out. That comes 2. The other 2 leaves inside, so 2 root 2 is the square root of 8, positive and negative there. And then I think I have 20 right there. Similarly, factor out the t first, and then you have basically the same setup as 19 was. So do all that, and you'll get down to positive and negative 4 and positive and negative 4i in this case, plus the 0. And we did 21. So back down to the bottom. There's 23, negative 9. 9 plus or minus 9 root negative 3 divided by 2. So this guy, I just went quadratic formula on him. This I could pull out that and make it an I. I want to be technical. There's 24. One of our answers is 8. The other 2 answers are negative 4 plus or minus 4i root 3. Yeah, that one I pulled out the I. I don't know why I didn't on the other one. And there is 25. Again, use substitution here. 1/4 is half of 1/2, so we can use it. We put that in, then we get u squared, regular u, factors of 15, they add to negative 8, negative 3, negative 5 will work. ZPP to solve for u, sub back in x to the 1/4. And in order to undo that 1/4 power, you raise it to the 4th power. So 3 to the 4th is 81, 5 to the 4th is 625. Questions there so far? I don't know what happened to 22. Apparently, I didn't get that one. Oh, wait, nope, here it is. Out of order. There we go. 22. Similar setup. Use substitution, factor, sub back in, solve positive negative 3, positive negative root 2. And then the word problem, right? Designing a picture frame. You can have a square piece of glass in the center surrounded by a decorated ceramic frame. That sounds like a terrible idea. Ceramic is heavy and fragile. Why would you do that? Anyways, which will also be a square. Dimensions of the glass and frame are shown at right. I have no idea who does this, how they did. It's probably, right, ceramic comes from clay. She only has enough material to make 27 square inches of frame, okay? Because it's got to be so thick, whatever. So she wants to know, okay, how wide is the frame going to be, and how big of a piece of glass do I need to buy from the store to stick on it, right? So what we need to work out is, first, how would you model the area of the frame? Well, it's this times this minus the glass in the middle. Okay? So x squared minus 3 is what they give us. Square that minus, like this is just x squared. All right? And I did a sneaky here. I use substitution again first, and then I could simplify the distribution there before things got messy and I had things to the 4th powers, right? Distribute, combine like terms, reduce, and then, sub back in the x squareds there. So it's good for not just solving, right? It's like, hey, this is a little ugly. Let me simplify it, work with it. I don't have to rewrite all of those exponents every single time. Just save yourself the trouble. All right, and then we need the dimensions of the glass and the frame. So basically solve for x and then plug it back into each piece. So here I used my U sub form again, factored that guy, found those numbers that worked, -9 and +2, ZPP. So for U, get 9 and -2, sub back in the x squared. Oh, x is the square root of 9 and -2, only one of which will make any sense. I'm making a real thing here. I cannot have a complex length. I cannot have a negative length. Okay? So only one of those numbers, +3, will work. So the glass in the middle has to be 3 by 3. Put that into your expression for the frame's dimensions, and you get, it's got to be a 6 by 6. I think they told us the units were inches. Yeah, because this was 27 square inches. Yep, we're dealing with inches. Oh yeah, there it is, inches. Okay, any questions? That guy. Questions in general? So you have a worksheet that is more practice of use substitution, the first page of which is just practice writing out the substitution where possible. There's a couple of them on there where it's not possible. You got to identify that. Hey, wait, this power is not half of the other power. It won't work. Okay? And then the second page is where you actually are asked to solve the whole thing. And so remember, you need to count up your number of answers. If you substitute an x to the 4th power, you'll solve and you'll get 2 values for u, which then have to split and turn into 4 values for x, right? So don't forget that part. But it's one of the guided sheets. It's got the reminder of the formulas right on the top of it. You know, there's an example for each one for you to reference right on the page. Easy peasy. I'd bring it up on my screen, but the only one I have ready to go has all the answers already on it. I didn't want to spoil it for you. So I will show you that one tomorrow, okay? All right. Any questions then? No? All right. Then I'll leave you to work.